What is energy, really? In the last video, we asked what light really is, and we found something strange. Light is not quite a wave in the ordinary sense, and it is not quite a tiny, solid particle either. It is a disturbance in the electromagnetic field, a ripple, a pattern. And that ripple carries energy. But that leaves behind a deeper question. What is energy? Because we use that word as if it is obvious. Light has energy. Food gives us energy. A battery stores energy. A moving car has energy. A star releases energy. But when we ask what energy actually is, the answer becomes surprisingly subtle. Not because energy is mysterious, but because energy is not a thing in the way we usually imagine things. You cannot point to energy by itself. You can point to a flame. You can point to a moving object. You can point to a beam of light. But energy is not sitting there as a separate ingredient. It is not a glowing substance inside the universe. So what is it? At its core, energy is a conserved measure of change in a system. That sounds abstract, so let's make it intuitive. Imagine water held high behind a dam. The water is completely still. Nothing appears to be happening. And yet, you immediately understand that something could happen. If the gate opens, the water can fall, it can turn a turbine, it can generate electricity, it can move machinery. So even before anything moves, there is already a kind of possibility built into the situation. Not because the water contains a special substance called energy, but because the system has been arranged in a way that can produce change. The water, the earth, gravity, and the height of the dam together form a system. And energy is the number we use to describe how much change that system can create. Now think of a stretched bow. The arrow is not moving yet. The string is not moving yet. But there is tension. Release the string, and the arrangement changes. The bow relaxes. The arrow moves. Again, energy is not a material inside the bow. It is a measure of the system's ability to change from one arrangement into another. This is the key idea. Energy belongs to systems, not just objects. A rock on the floor has one amount of gravitational energy. The same rock, placed on a high shelf, has more, but the rock itself may look exactly the same. What changed is its relationship to the Earth, its position within a gravitational field. So the energy is not simply inside the rock. It exists in the arrangement. The system. The relationship. Now consider motion. A still ball and a moving ball are different. The moving ball can knock something over. It can transfer motion. It can cause change. So we say it has kinetic energy. But again, the energy is not a small object inside the ball. It is a measure of what that motion can do. Heat works the same way, but at a smaller scale. A hot cup of tea looks still, but inside it, the molecules are moving, vibrating, colliding. Heat is not a separate substance. It is microscopic motion. So thermal energy is the energy of countless tiny movements inside matter. Chemical energy is another arrangement. Food, fuel, and batteries store energy because atoms and electrons are arranged in particular ways. Change the arrangement, and something can happen. A battery can drive electrons through a circuit. Food can power the chemistry of your body. Fuel can burn and expand. Different forms, but the same underlying idea. Energy measures the possibility and amount of change. And here is the remarkable part. When change happens, energy does not disappear. It transforms. The water behind the dam falls. Its gravitational energy becomes motion. That motion turns a turbine. The turbine produces electricity. The electricity becomes light, heat, sound, or movement somewhere else. The form changes, but the total account remains balanced. This is why energy is often compared to money. You can exchange forms. You can move it between systems. But the total can always be tracked. Energy is like that, except the universe keeps the records perfectly. No mistakes, no missing amount, no hidden loss. When people say energy is used up, they usually mean it has spread out into a less useful form. A phone battery runs down, but the energy has not vanished. Some becomes light, some becomes signals, much becomes heat. It is still there, just more spread out. This gives us a clearer mental model. Energy is not stuff. Energy is a conserved measure of how change can happen in a system. It tells us what transformations are possible, and it tells us that every transformation must balance. Now let's bring this back to light. Light is a ripple in the electromagnetic field, and that ripple carries energy. But now we can say this more carefully. Light is not carrying a substance. It is carrying a pattern of change in a field. A photon is not a tiny hard ball of energy. It is a precise packet of disturbance. And when that light reaches your eye, the pattern changes form. The disturbance becomes chemistry. Chemistry becomes electrical signals. Those signals become perception. A beam of light becomes sight, not because something solid traveled through you, but because change moved through systems while the balance remained. So when we ask, what is energy really? Energy is not a thing. It is the conserved measure of change and possibility within a system. It tells us how much change can happen, and it tells us where that change can go, and it never loses count. So energy is not part of reality in the way objects are. It is part of the structure underneath reality, a hidden rule that keeps everything consistent. And perhaps that is the deeper idea. Reality is not made of solid things. It is made of systems, relationships, fields, and patterns of change. And energy is the measure that follows those patterns wherever they go. However much the world changes, something underneath remains perfectly balanced.